Hello, good evening, good morning, good afternoon. Um, Glad you're all here. Thanks for joining in and give me something in the chat like hi or exclamation mark or at sign to make kind of to test my audio and video so you can hear me. Just type something in the chat. Hello. Yeah, thanks for dropping messages in the chat. And yeah, thank you. Thanks for confirming that it's all good. All right. So, my name is Alex, and today we are going to talk about running Kubernetes on OpenNebula. So, how you can do that, what are the things to be aware of, and yeah, so that's the plan for today. Now, if you would like to follow along, I hope you brought your instance with OpenNebula. So what you need is like 8 to 10 core, maybe 12 core CPU, and at least 16 gigs of memory to follow along if you'd like to. This is going to be recorded, so if you'd like to try it after that, yeah, then feel free to wait for the recording and then just follow along with the recording. Again, would like to remind you that the easiest way how to install OpenNebula is Mini One. Uh, just search for it and or again check the webinar page. It has the exact command that you need to run in order to have Mini One up and running on your system. So yeah, that would be the thing that you need in order to follow along. If you're not following along but just casually watching, then it is also fine. Then just enjoy the enjoy the webinar. Right. Again, our agenda for today, we are going to discuss OneKE architecture. That is the OpenNebula Kubernetes Engine. Then we are going to talk about the template or templates that we have there. Then we are going to deploy OneKE and also talk about scaling a little bit, as well as going to connect to that cluster using kube command, kube control. And after that, I'm going to deploy an application to that OneKE cluster. So yeah, it should not be that hard. And in the end of the day, we are going to have some kind of application up and running. Now, first of all, before we are going to proceed to the OneKE itself, we need to discuss one small thing that we have in OpenNebula called service. So, what the service is. If you're familiar with OpenNebula, I hope you do, then you know that basically you are running virtual machines, and then your virtual machine is configured to serve some kind of a need, and then you also can uh, either go with a blank VM or slightly fine-tuned. Now, service is something that unites virtual machines and deploys them as the single entity. So service is the multi-VM deployment, right? And in order that to work properly, you need a few additional things that obviously OpenNebula is packed with, but you need to run one flow and one gate processes. So again, these, if you run with Mini One, these are up and running from the get-go, so you don't need to perform any extra steps in order to uh, get it running. But if you're installing it manually, make sure that these are up, running, and configured. Now, service is something that, as I mentioned, it kind of unites VMs and deploys them as a single entity. But even though these are deployed as a single entity and are visible as a single entity in the service page, in the um, in in the virtual machine list, each virtual machine is accessible individually. So even though you deploy and presumably destroy also or terminate service as a single entity, you still have access to the individual virtual machines if you need to, for example, troubleshooting, maybe some slight reconfiguration if you'd like to, or I mean, whatever the case may be. Now, also service is scalable in both directions, right? So you can scale to increase the number of virtual machines, or you can scale down and to, let's say, go from having like 4 VMs to 2 VMs, if that's your case. So that is again the benefit of a service. Service can be scaled both manually and automatically. So if it comes oh, if we talk about the automatic scaling, then that would be something that you will need to define in the configuration, right? Before you deploy, there are various triggers. Again, it's up to you on which metric you would like to deploy, but you basically have two options. You can scale based on the some specific metric, right? Or you can scale based on time. For example, we know that there's school break or spring break or holidays, whatever, is in a few, uh, every Christmas as the example. And we know that, the kids are coming from school, so they pretty much less occupied in during that time. So, and we are hosting some kind of, the gaming service for them. So we know that the possibility that the demand for a service is going to increase is pretty much high. So what we can do, we can say that on this specific date of the month, or every Friday every month, let's say, we are increasing the number of worker nodes. So from, let's say, 2 to 10, because again, we know that there will be a high demand. And then we scale down on Monday or after the holidays, because we know that, well, that's it. Everybody goes back to their work and school. So that's why we can scale down. So again, all that can be achieved using service. But as I mentioned, you can also do it manually. So if you feel that you need to scale up, or if you feel that you need to scale down, you always can control this thing manually. And one important thing that we always need to be aware of is that when we talk about service, we actually talking about roles, right? Because your individual virtual machines are combined into the roles, and you are scaling roles, right? So that would be the um, minimal entity that a service is working with. It works with roles. So that is a new concept, a new terminology that we need to memorize. Now, when it comes to service, excuse me, let me just quickly switch to a light mode so it's much better visible. Okay, and right. So um, all our service templates are going to be available under the service template. So again, if your virtual machine templates are available under the VM templates, then your service templates are available here. So keep in mind that even though we have service template, right? Even though we have service template, the uh, service still, in the end of the day, launches virtual machines. So service template is not going to substitute your VM templates. So basically, just service template is one level above of the virtual machine templates. right? So keep that in mind. Right. So you can create your service templates manually, right? Uh, or you can download these templates from the marketplace, so from the OpenNebula marketplace. We have multiple things called service, right? But in this case, that's going to sound a little bit funny, but not every service is a service, right? So if you have a service in the name, that kind of doesn't mean that it's a service template, right? It may be like in case of Minayo, this in this case, the service is just in identifying that this uh, virtual machine holds some kind of a service. So it's not just an operating system, right? So it's a service. Now, if you'd like to, you can always filter out by the type and get service template. So now we see it a little bit trimmed, or less trimmed down, and we got rid of any individual virtual machine template and images. Also, you can see here that the one I mentioned, Minayo, it's still there, but this time it's a multi-node. So it basically launches multiple Minayo uh, Minayo instances in specific configuration, of course. So yeah, if we talk about getting the service like OneKE in this case from the official OpenNebula marketplace, then I would suggest you to apply a filter and locate one. So right, we have different versions here. Again, every version has its own benefits, obviously. So it, you might go with latest and greatest. You might go with something stable. Again, check out that the dependencies matches, because, for example, some newer uh, OneKey may not be compatible with your older OpenNebula version. But I'm going to play it on the safe side. I'm going to get 1.29. Now, just click export that and select where to download. So it's important to export all the associated virtual machine templates and virtual machine images of OneKey, because it has multiple virtual machine templates that it needs to download and even more images that it needs to download. And select your data store. Again, if you are following along, then typically then you're running the mini one, and if you're running mini one, then you uh, are running it with one single data store. So there is a no-brainer which one to pick. So now it's going to start uh, the importing phase, and we already can go to VM templates and have a look on how many virtual machine templates we have here. So Alpine Linux, this one comes with the menu one deployment. So don't look at this. We are interested in this three virtual machine template. So we have the VNF, we have master, and we have storage, right? So three virtual machine templates are going to be there. Now, basically, that almost corresponds to roles that we have uh, in uh, in the OneKey. Now, about OneKey, as I mentioned, it's a service from the marketplace. I mentioned roles before. We have four roles. That is the VNF, which is basically the virtual network function. Then there's a master, there's a worker, and then there's a storage. So totally we have four roles. Now, under the hood, basically that deploys the uh, RKE2 based Kubernetes environment. So so we are using Rancher in order to and basically what you'll get the rancher there. And we also CNCF certified installer. So if you're looking for CNCF certified installer, then that's where you can find it. Now, look at this at OneKE from a perspective of a managed like service, right? So if you go to some cloud provider and you would like to have Kubernetes, then basically you as the user going to click next finish, and you are receiving the Kubernetes cluster. The experience here is pretty much the same if you are a user, because you again just go next finish and you get the Kubernetes cluster. Everything else is controlled by OpenNebula under the hood. And the idea of OneKE is that you're not only running Kubernetes cluster, but you're also getting that managed Kubernetes instance experience. Right. So as I mentioned, we have 4 roles in total. So there is the VNF role, then there is the master role, worker role, and storage. Now, VNF is the virtual network function. Basically, it proxies the API request to your control plane. It runs HA proxy and Metal LB. So all that can be configured separately. Now we have master role. So this one runs the etcd, control plane, and API server and scheduler. So that is quite important, right? If you'd like to control your Kubernetes instance. And if we're speaking of bare minimum, then you should have at least one VNF and at least one master. So typically, masters are not running any workloads, and they kind of shouldn't. The next option, the next thing is worker role. So worker role actually runs the workload. So you can have them as many as you wish, and that will form your cluster of the actual worker roles. And then there is like the fourth option here, the fourth role, that is storage role. So this one runs the Longhorn based storage. So you can have some kind of persistent storage. And this one is not running any workloads as well. So it's only dedicated to run a Longhorn based storage. Now, by default, out of the box, if you just blindly click next, finish without tweaking, tuning, whatever, you will get the VNF role. So you'll get one VNF, one master, and one worker. So you can scale it, you can pre-configure it in a different setting, but that would be the bare minimum that you are going to receive if you're not going to change anything. Right. So for that, we have 3 templates. So again, you may already have a question. Wait a second. You told us that you have we have 4 rows, but you have only 3 templates. Why? How is possible? Well, actually, yeah, it's the magic trick that we are doing. So we have by default our worker and master. Basically, these are running the same virtual machine template. The only what differs is obviously the post configuration once you deploy the cluster. So that is something just to keep in mind. Although it shouldn't be like that all the time, and feel free to change that. And yeah, we're going to change that. So for example, because master may be less powerful, maybe you don't need as much power as you need on the worker node, so it would be a good idea for you to separate them when you are going to run it. Now, okay, three templates. That question answered. Let's go to images. As you know, virtual machine template is just a set of specific configurables, but the uh, image is something that basically virtual machine template is going to rely on. So if we go to images, you will find that we have, well, 4 images. So now again, you say like, hey, Alex, wait a second. We just dealt with 4 rows, 3 VM templates. Now you say you have 3 VM templates and 4 rows. Oh, sorry, 4 images. Why? How's that possible? Now, here is the thing, right? If you look at this, you see that one is VNF, so one for virtual network function, one is for master, and we have 2 for storage, and they also differ in size. Now, 2 for storage, that is the trick, right? Because there would be a one separate image. In this case, this one is an empty image. So one separate image for the persistent storage. So one is the operating system itself, and one is the persistent storage. By default, it's configured to be 10 gigs, which is again fine just to test it out, but you may want to increase that, and you can again do it either before you deploy the virtual machine and just uh, scale it to something greater, or after you actually deploy virtual machine, you can resize this image and make it bigger as well. So again, totally up to you how to do it, but just so you know that by default, it is going to be 10 gigs in size. Okay, now I've answered that small itch that probably you had during the overview. Now, scaling. So what you should be aware of, that every role is scalable, so you can scale every role, right? And by default, we're going to get the VNF, master, and worker. So there is no storage enabled by default. Now, let's going to have a look at the actual deployment of the cluster. Now, we can go to, but before that, let's actually stop here for a bit and let's talk about the service template. Now, service template is something that we also can adjust, right, before we going to instantiate the service. And it has the network configuration, right, with definition. So what would be the public, what would be the private type of network. Now, OneKE runs with 2 networks. One is public, one is private, and ideally, you have public connection only for the VNF node, and private are basically they are for masters, workers, and storage nodes. So the only role that has 2 network connections is is VNF. Now there's a bunch of the user inputs which we are going to cover slightly later, and it's also this one. So that is quite important here. So while everything else was just okay, this one is actually very important. The deployment strategy. Now, by default, deployment strategy is set to straight, which basically means it is going to respect the parent-child relationships. You can go with none, and in case of none, it is going to deploy all the VMs, all the roles in a single shot. Now, if you go with straight, then it's going to respect the dependencies. So let's say in our case, we don't want any other role to be deployed before we deploy the virtual network function. So because that gives the networking to all our masters, workers, and storages, right? So that's why the straight strategy would be the best fit here. Again, that depends on your service. In this case, straight works, but sometimes if your service consists of multiple VMs that they don't have this kind of dependency, then feel free to change it. Now, you also can have some scheduled actions. So the scheduled actions, you can schedule some backups, some reboots, some snapshots, and so on and so forth, and then set where you would like to perform these. So now here's where the fun begins. Now you have all your roles with a number of VMs that we are going to deploy when we deploy the service. Now we deploy one VNF, right? And we deploy one master, we deploy one worker, and no storage. Now, as you can see, there is another thing that is missing here, the parent role. So VNF has no parents, while master, worker, and storage, they all depend on that VNF role. So only when VNF role is reported as deployed, the master, worker, and storage are going to get deployed. So again, this is quite important, this dependency. Now, the next thing is where it mapped to. As I mentioned, service is just the one level above, right? The VM templates. So you need those virtual machine templates to be there. Now, and then this is where you are mapping your masters, your workers, your storages to a specific virtual machine template. And this where you can see that the worker is actually mapped to a master. Now, can we change that? Yes, of course we can. Again, it should just must follow some specific logic. And in order to do that, the best option would be just clone the existing template. So let's have a look. Uh, in order to achieve that, I would actually switch to the command line because it's a little bit faster, easier. And again, let's stop looking at the UI and let's switch to the command line. So one template would be the command that shows all the templates that you have and with so manages all your templates, and with the subcommand list you can uh, list all your templates. Now we have three templates. As I mentioned, our worker comes from the master, right? So it's the same template. So it would be a good idea to clone this template, right? So that would be one template clone, then the name or ID of the template. So ID here, name is right here. So if you'd ask me, I'm the ID guy here. So I prefer IDs because they are shorter in the first place. Second, that is less likely I'm going to make an error, because if you have white spaces here and there, if you may have some special character, you need to escape that. Well, to me, the uh, the ID is the simple way. Although when I'm setting the name for a target template, I need obviously to set a specific name. So I'm going to follow the same pattern as we have here, right? But instead of the master, I'm going to set to worker and 3 because, well, that is the third template of the service OneKE. So again, I'm going to just follow the same logic as OpenNebula follows, just for sake of consistency. So as the output, we got it here. So that is the ID of our new template, right? So if we are going to list the template, you can see it right here. Now, here's the thing. What about image? So let's list our images. Hey, there is no any worker image. There is nothing there. Why? So uh, just so we are on the same page. The thing with templates, so the templates can refer to the same image, as it is in our case, the worker template and the master template both are going to use this image. Because in this case, we don't need a separate image for that. I only want to have a separate template, not a separate image, right? So, and by default, that's the default setting. When you clone a template, it is only going to clone the uh, the template. not going to create a clone of an image. You can do that again if that's your thing. Then feel free. Again, it's the way you wish, either command line or the GUI. So just go there, clone, and check this checkbox, and it's going to create an clone of the image as well. But again, in my case, I don't want to waste extra space, and to me, they're perfectly fine to use to rely on the same template, right? But again, the only thing that I may want to do, I may want to just make my worker a little bit more powerful. So let's do one template, update, and again, I'm going with ID, right? So you can pick the name. I like IDs. Now, what's going to do? It's going to open this template in the text editor, so you can edit these parameters. Now, in my case, that's the VI or Vim. In your case, that might be anything else. So that just depends on what is configured on your system. Now, memory is what I would like to adjust. So I'm pretty fine with everything, but I just want to add a 1 gig extra of memory. So I will save it as 4 gigs or 4096, even if we are editing via the command line. All that editing can also happen via the GUI, so via the Sunstone. Feel free to choose the way you wish. So I just do it in the command line as it's slightly faster. Okay, so template is updated. Is that it? No. I've updated the template. I've created a template, right? So now we have an extra template there, but it's not mapped yet. So my service template is not benefiting of these extra template yet. So I need to go to the role definition and I need to redefine from master to worker. So now it's going to use this template. Again, what else you can do? You can add more VMs here. So start more workers. You can start more masters. You can start more storage. Out of the box, it's totally up to you. Again, depends on what your needs are. And the last thing is the individual role configuration. So that's where additional fun begins. First of all, is the definition of networks. So which networks are available. In case of VNF, we do want to map it to public and private, right? Because that basically is a proxy. Plus, additionally, that also going to you can configure it to be as the proxy for your application, not only to proxy the kubectl requests. Then what else you can define here is the role elasticity. So role elasticity is also known as scaling, right? So you can define the different policies. So when to scale and when to trigger the scaling. Elasticity policy, it's basically when it performs a change or some kind of adjustment, basically scaling based on a specific parameter, so that you can get from the monitoring. Or scheduled policy, this one is going to perform the scaling up or down based on a specific timestamp. So, for example, you can just change this role to 3, and it starts at a specific time. And the time expression is basically a cron tab expression. And you can have, obviously, just something there, but you can have multiple policies, right? So let me close that. We don't need it. Right. So that is what you can configure there if you would like to go into that automatic route. But again, think of it carefully. So because once you deploy it with this policies. So you would like to pre-configure these policies upfront. Next is the cooldown and minimum VMs. So these are two very important parameters. So the cooldown period, when scaling is performed, then there will be a cooldown period. And right here, it's 120 seconds. Now, if you are not going to configure anything here, so if you are going to delete the cooldown period, then it's going to use the default one, which, if I recall correctly, is going to be 10 or 5 minutes. So something like that. Again, you may want to have this cooldown period to be shorter, so that's where you can define it. And also the minimum number of VMs. So that means your elasticity policies are not going below that number. Now, here's the catch. Let's set it to 3. Let's try to finish. And we get an error. Why? So why we get this? The thing is that your minimum VMs, your under your role elasticity, cannot be greater than your number of VMs that you are going to deploy when you are going to deploy the service, right? So this should be either equal or greater than this. So again, this is something to keep in mind. So you cannot just start one, but then uh, start like one, but then say I don't want it to be less than 4. No, it's not going to fly. So you must have um, the same amount or greater. Right. So I've just edited my OneKE template, and then it is ready to be deployed. Now just press the instantiate, and here's the thing. Here's the good thing, I would say even. The good thing is that you can kind of instantiate multiple services with the same configuration. So they are following the same pattern, right? So just change the number here. Obviously, what you cannot do is to set it to 0 or keep it empty. It's supposed to be 1 at least, which again is kind of logical if you think of it, but just keep in mind. And also, it's supposed to have at least 3 characters in the name. So if I will try to do K8, it says, no, 3 characters, please, right? So these are like the kind of requirements that just you want to be aware, right? Now, these are inputs. Where these come from? Yeah, right. So these were defined at the template level for every service. Every service has its own user inputs, but again, in our case, we have the Kubernetes related inputs that we can configure. Now, that would be the control plane endpoint, virtual IP, the default gateway virtual IP. So why we need that? You see, the VNF role. So this one is for the VNF role. So VNF role, you can run multiple VNF roles at the same time. So and then in order to somehow to communicate with your cluster, that should have like common IP address. So that's why you need to define the common shared virtual IP. So if you're running multiple VNF roles, if you're running only one VNF role, then it's fine to just leave it empty. Same for the default gateway. So the VNF, it's like the networking, right? So and since it's a networking bit, it also going to provide uh, the the uh, the default gateway function for all other roles. And again, you can have multiple VNF roles. So if you would like to have that, then giving it a good internal virtual IP address is a very good idea. Now, if you are adding the control planes endpoint VIP, then also don't forget to add it to your certificate, right? Because you don't want your kube control command line to swear on a bad certificate. Now, what else you can have here? You can enable Multus if you need to, right? You can enable Metal LB, again, if you need to. Then, if you would like to run a storage, then you should enable Longhorn. You can adjust it, so the storage file system and where the storage is mounted. Um, it's fine to go with defaults, but yeah, if you are updating the template to look different or to have different storage or different image as the Longhorn storage, then feel free to adjust it as well. Now you can enable traffic. So traffic is going to proxy the request, and also you can use it uh, as the proxy for your application. So let's enable traffic. And then the rest stuff is something that we also better to enable. In this case, the DNS, the NAT, and the router. So router, this one tells the router IP addresses that virtual network function is going to use, then the outgoing interface for our traffic, and also the DNS. So it acts as the DNS recursor. So again, what you would like to have with it, you would like your worker nodes, your storage nodes, and your master node to be in the private subnet, ideally. So you cannot just uh, get there from any place, right? So you would like it to be isolated, but you also would like it to have some kind of access to the network, or at least download images and do that kind of stuff. So for that, these are the switches that you would like to have enabled. Obviously, you can disable it, right? But what you need to be aware of, you should think about it upfront. So you should enable them upfront, because that is the configuration that it will be handed over to the VNF node and to the Rancher node, Rancher configuration daemon, aka Rancher agent. So you would like it to be defined during the deployment stage, because after that, well, you get the typical Kubernetes cluster. So there is nothing added, right? So it's typical RKE to Kubernetes cluster. And if you'd like to reconfigure it or to add anything new, so that is going to be your typical Kubernetes configuration. So this is going to make your life easier when you deploy, but after you deploy, you are left off with obviously typical Kubernetes tools. So once you enabled all that, you need to map your public and private network to a specific. Oops. While I was talking, I got timed out. That happens. Probably that means that I need to speed up a little bit. Right, so that's going to be KHS. We would like to enable this. We would like to enable this. Right, and now we go to existing. Right, so we have the public and private networks that our service is going to work with, and we must select the existing network here. So again, I can select whatever I want. Obviously, it must make sense, right? But yeah, I will map, and you also should map both your public and private to the same virtual network that's created um, by the mini one. Obviously, in the production, these are supposed to be different, but for now, for sake of simplicity and to make sure that everything works, let us just go with both mapped to this virtual network, right? And let's press finish. Now, Kubernetes cluster is now in the stage of deployment, and it's going to take a while. You can go to roles and you can see all the roles and their current state, right? So we can see that storage, and we actually can find this called cardinality. So basically, that is the number of virtual machines that this role is supposed to have. And storage logically has 0 because we are starting it as quite empty, while VNF, master, and worker has at least 1. Now, I cannot do anything with this setup yet, right? Because I need to make sure that it is up and running. If you go to your virtual machines, you can see that VMs are there, right? So the naming of the VM is the role, the ID of that virtual machine, and then the name of the service. So it's service 1, service 2. Obviously, my KHS is the actual name of the service, but in this case, it tells that it is. So this one came from a service with the ID 1. And if we look at my service page, this service has the ID 1. Cool. So you can see your virtual machines up and running and with this in the state running, but it's not actually there yet. So once you roll it out, there is the post configuration happening, right? So that is quite important. And uh, you can connect to each individual virtual machine and check the state, right? So let me connect to master node. So let me take the IP address and let's do SSH root at this one. So I've just connected to this VM, and you can do, if you follow along, then you can also do that. And you can see that currently my OpenNebula OneKE master node is in the configuration state, right? So it's not there configured, right? So again, that's what I said, that if you see that your virtual machine is running and state is green, that does not yet mean that it is ready yet, right? So you need to wait until the actual post deployment configuration is going to happen. Now, if you are going to log directory, there is the one appliance log, and one appliance log has the configure and install. So these are the logs that you would like to have a look, right? To make sure that it is running. So, right. Now, your service is there, your service is up and running. And if you would like to scale it, you need to pick up the role that you would like to scale, right? So, oh, excuse me. I don't know why. So, pick up the role that you would like to scale and press scale and set the desired number of VMs that you would like to have. For now, I have all my virtual machines set to uh, set to 1. And for example, I would like to add storage. So I will need to scale it and set 1 here. So if you'd like to remove all the nodes, all the VMs from that role, then you will need to set it to 0, right? So let's try and scale it. Oops. Once again, scale, scale, right? So again, this is very important that you can um, you can scale to uh, to you can scale only one role at the same time. So that is number one. And second thing is that again you need to be aware of is that once the cooldown period kicks in, again, you cannot scale anything or make some certain operations during the cooldown period. As you can see, the cooldown period is here. So in the command line, you can use OneFlow top, right? So OneFlow would be the command line to control your service deployment. And you can use OneFlow top, and this is going to automatically refresh in the background and is going to show the state of all your services. Now, as you can see, it's in the cooldown period. So it's in the cooldown period, so we cannot do anything with this service at the moment. So we cannot actually try to scale it up or scale it down or do anything with it. So we need to wait until the cooldown period is going to get finished. Yeah, while we're waiting, maybe we have some questions. Okay, no questions. Yeah, so we can see that the KHS cluster got scaled. Now we have additional virtual machine, right? So here it is. Okay. Yeah, let me have a look once again. What's the current state of my master node? Well, it may happen that we might need to redeploy it once again. So yeah, let's have a look. So again, one VM list. Let me list the virtual machine. So I need to connect to this guy and check its state. So that would be, yeah, it's still, for whatever reason, is in the progress. I might need to redeploy it. Let's have a look at the log. So installation completed. Let's look. Yeah. So for whatever reason, it tells that invalid IPv4 port for VNF HA proxy 0. Okay. Let's redeploy that. Okay. So let's go to service templates. KHS 1. So Longhorn traffic. This one existing. Okay. Let us have a look again. So the VNF is getting deployed, right? So as soon as VNF deployed, we're supposed to have other VMs there. So let's have a service, look at the service. Okay. So storage, because in this case, again, it's 0, so nothing's there. Let's refresh. So okay, here is the master. Here is the worker. Okay, so again, it's in the, if we would like to have a look at the log, see that's currently deploying networks. Right. So virtual machines are there. Now, if we look, so it's also interesting and worth to mention, if we are going to look at our IP addresses and virtual networks, then you can see that the VNF node, so it has 3 IP addresses, right? So while, 2 IP addresses, while all others, they only connected with 1 IP address. Again, it's because the VNF has the connection both to the public and private network, while master worker both are only running the private network, in the private network. Okay, so let's have a look at our virtual machines. So here they are, virtual machines. Let's go there. Yeah, it's also still in the configuration. So again, it may take some time in order to get it configured. And we can have a look at our appliance. Okay, so the configuration is in the process, which is good. So yeah, in case that I try to speed up a little bit, so I would not recommend to try to scale it, obviously, before before you have all your workers and all that configured. So that is something quite important. And meanwhile, I would like to install kubectl, right? So I would like to install the command line of Kubernetes just to make sure that I'm all set when time comes. Right. Okay. So kube control is there and it is up. Right. So I'm all set. Then let me have a look again on my virtual machine, how it feels itself. Is it still configuring? No, that is something that we would like to have to see that it is ready to do the thing. Now, here's the catch. We would need our kube command line to be configured to work with this cluster, right? So typically you do it by supplying the specific configuration file. Now we can get it because the thing is with this is that master node actually is keeping that um, keeping that configuration file in its attributes. So there is a specific command line that we can run in order to extract that and configure our kube control command line to work with it. So, but what for that, what we need to is extract this. We need to have the ID of that um, virtual machine. So we are going to use one VM command line with subcommand show, and then we need to supply this ID, right? So in this case, that is the uh, ID of um, ID of the virtual machine, right? So that would be one. Then what else we need to do? We need to export it, so show it as JSON. Because if we go without J, it is going to show us the uh, all the attributes in the human readable format. But what we would like to achieve, we would like to use some kind of parsing in order uh, to extract the file. So that's why -J, then pipe it. And the next command is quite lengthy. So I'm going to just copy paste it, but you can find it in the documentation. And basically what we are doing, we are using the JCube parser to extract the OneKE kubeconfig and and change the encoding from base64 to something more readable and processable. And then we're going to install it as the config for our kube. Right. And if I'm going to do get nodes now, you can see I have two nodes, right? One is running the control plane and one is running the workloads. Now, again, I still would like to have the Longhorn storage here as well. So I would like to scale it. Now, how to scale it? I already show you. You can scale it from the web UI, but now let me do it from the command line. So one flow, scale. Now you have service, right? Now then you have role. So again, let's do list first. So one flow list. We have ID1. So one flow, scale 1, and then role storage 1. So that is going to force the scaling. Let's have a look at now OneFlow top. See, the state is scaling, right? We can do the same with one VM. So one VM top. And you can see that the storage virtual machine is also up and running. And now again, the magic happens behind the scenes. So the RKE2 agent is performing this post-deployment configuration to join the cluster as a storage. So we always can do watch kube control get nodes and then wait until the storage node is going to appear here. So might take like 2 to 3 minutes. So again, in order not to wait for too long, let me download a simple app. So that's a simple test application. So it's nothing there, just the Python web UI that just has some kind of a basic application, right? So that is something that I'm going to deploy. You can find it as well. So so you can find it right here. I will show you on screen. So you go here, and here it is, the test app. So just go to my GitHub, and I'm going to try to paste this one in the chat, or I will ask the colleague of mine to put that in the chat for me. So just a second. This, because obviously I cannot do that myself. Cannot paste some shady URLs. Right. So, but that's basically the test application. Again, it's nothing there, just a simple, it's going to deploy a simple container, and that is just basically a set of YAML files that's going to deploy an application, a MariaDB database, and is going to expose it as the service. So as simple as that. Now, let's do one VM list. Number 3, let me connect to my VM, and we can see that Longhorn storage VM configured. So then we also should see it in the nodes, right? Cool. So we have our worker, we have our persistent storage, we have our control plane master, and we also have kube control configured. Right. So now it's time to deploy a test app. So let me extract my test application, and let me do the command, which is kube control, right? Apply -f test app. And as you can see right here, that it is going to deploy all the necessary services. Now it's going to deploy the ingress router. It's going to deploy the service itself. So kube, let's get service. So we have MariaDB and test app as a service. So kubectl get pods. So we also have both pods. Now, and kubectl get ingress route. We have the test application ingress router, right? So basically, all that tells us that my application is up and running and pretty much healthy, right? So what we need to do right now, we need to connect that VM. So yeah, let's try to do that. Now you can just use the IP address of the VNF node. So remember to use the public IP address. You can copy it from here. Or additionally, you can do something like VM show 0 in this case and locate the IP address of that virtual network. Obviously, you can do it with a JSON and parse it as JSON, so up to you. But that is my initial idea. Okay, so here it is. We just did curl to that IP address. Again, that is the IP address of the VNF node. And VNF node proxied the us to the application, right? So, and what it does actually, it tells that it has three simple functions: create database, insert dummy data, and then get the dummy data. Right, let's try to do that. So curl create database. So it's initialized the database and created the data table. Now then we need to insert dummy data, right? We can do it a few times, right? And now we can get data, and that prints out the data that we've just inserted. So what effectively does, it just inserts the timestamp and just generates the random number and the ID of that data. So yeah, that is how this application can get exposed to our to the public. And obviously, if you have all your routing properly set up, then initially you can also make this application available on public. In this case, routing is not set up in a specific manner, so that's why it all remains within the private subnet of that server or these servers. But again, with the help of specific configuration, you always also can expose it further to the actual public. So just make sure that your routing is set up correctly. Right. So what we have right now, we have 4 nodes that are up and running. We have each role, 1 VM per each row. And again, we can scale up, we can scale down if we would like to. And we also can work with the individual VMs. So as you saw, you always can connect to the individual virtual machines and perform some troubleshooting, read logs, and check if everything is healthy. Additionally, obviously, you can look for attributes, right? And in this case, our VM also going to report to OpenNebula when it is ready, right? So that is something that where OneKE kicks in. And if we would like to terminate the service, yep, we go there, select the service that we would like to terminate, and click delete. Alternatively, you can use OneFlow command line, right? So that would be the way how you can terminate this service if you need to, right? But again, be careful because, well, terminating the service actually terminates the VMs. And even if you have the persistent storage on your Longhorn, if you terminate the storage VM, it's going obviously to terminate images as well. So yeah, make sure you have a proper backup of your storage nodes in order to make sure that, well, your data will be preserved even if you are going to delete the service completely. But what it does, it's obviously going to survive the deletion of a container, of a pod, if I'm going to delete a pod, and will uh, redeploy the deployment. So I will bring the pod back. Uh, it's going to be mapped and it's going to grab the data from the storage node. So again, keep that in mind. For pods, fine, but if you'd like your data to be preserved even outside of that, make sure to configure proper backups of that node. Right. So thanks for attending. And I would like to ask, do you have any questions regarding the OneKE or anything that was shown today here? Feel free to use the chat. I'm actively monitoring the chat. So if you have any question, then feel free to drop it there. Alternatively, feel free to use our forum because, well, maybe you have a question or an issue that was already solved by our community. Or, well, if you just want to have a friendly chat with our community, then feel free to visit our forum. Alternatively, also sign up for the webinar sessions that we have. We have a bunch of webinars that we are covering multiple topics on OpenNebula, starting from the basics, how to use OpenNebula, down to some specific things like the migration from VMware and all new features of OpenNebula and the next release and so on and so forth. So yeah, follow the webinars page because we have a lot. And also feel free to sign up for our trainings. So we are running bi-monthly trainings, and these are public trainings where we are going from zero to hero and covering all the aspects of the Open Nebula, so you can start with Open Nebula with a confidence. Yep, always welcome to look in our documentation. So it's pretty extensive. So I would suggest you to have a look in the documentation as well, because there is a lot to unpack when it comes to OpenNebula. Okay. So I see no questions here. Well, thanks for attending. It was a pleasure. I hope you learned something new and see you in the next session.